In this video, we will explain how to factor trinomials over the rational numbers. The reason of the name trinomials is because these expressions, they have three terms. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And we are going to start with expressions in which there is only one variable, the variable x squared. And in this case, we will have an x squared, an x, and a term that doesn't have any x. Then when we have this part here, the coefficient of the x squared is called the leading coefficient, and we are going to first explain how to factor when the leading coefficient is 1. Then for number 1, we have x squared plus 5x plus 6. Then if the leading coefficient is 1, we just need to find two numbers, alpha and beta, such that the product is the coefficient that doesn't have any x, and the sum is the coefficient that of x. Then the sum is 5 and the product is 6. Notice that since the product is 6, then we may have the alpha and beta are positive both, or they are negative both. But since the sum is positive, then they both need to be positive. And then in this case, just by trial and error, we know that alpha equals 3 and beta equals 2. Then you can rewrite this as x plus 3 times x plus 2. You can check that this is true, and you can just check the answer by doing x squared plus 2x plus 3x plus 6, which is x squared plus 5x plus 6. Now let's do example number 2. Here again, the leading coefficient is 1. We have x squared minus x minus 2. And then we're looking for two numbers, alpha and beta, such that the product is the constant coefficient, the coefficient that doesn't have an x, which is negative 12, and the sum is equal to the coefficient of x. Notice that here we are looking for a product that is negative. Since a product is negative, that means that one must be positive and the other must be negative. Then here, when it says the sum, is actually the difference, because one of them is negative. Then when you try to write 12 as products, I think 4 times 3 has the properties that the product is 12 and the difference is negative 1. Then we can take alpha equal to, we want to be negative 1, negative 4, and beta equal 3. We can check that alpha times beta is negative 12, and negative 4 plus 3 is negative 1. Then this can be factored as x minus 4 times x plus 3. And again, we can check that this is true. If we expand, we get this, but we don't have to do it. Let's do example number 3. Again, we have the leading coefficient is 1. And if we want to factor this, then we look for two numbers. It's going to be like x plus alpha, x plus beta. And we want alpha times beta to be negative 3, and alpha plus beta to be equal to 2. Then since the product is negative, then one of them is negative and the other one is positive. And we want the product to be essentially 3. The only way we can write 3 is as 3 times 1. Then we pick, we want the sum to be positive and they must have different sign. Then we can take alpha equal 3, beta equal negative 1. Then the product is negative 3 and the sum is positive 2. Then we have x plus 3 times x minus 1. Okay, let's do Case number 4 is a little more interesting because the leading coefficient is not 1. Let's do this example. We have example number 4, and here we have 4x squared plus 7x plus 3. Then, in this case, the leading coefficient is, let's say, a equal 4. Then we need to look for two numbers with the property that alpha times beta is 3 times 4. We multiply the leading coefficient by the constant coefficient, and we have 12. And we look for, we again want the sum to be just the coefficient of x, 7. Then these two numbers, if we want the product to be 12, and the sum to be 7, is 4 times 3. And in this case, the product being positive and the sum being positive, it means that alpha and beta are positive. And then we have the numbers. But here is the only difference. Here we will write that this trinomial can factor as 4x plus 3 times 4x plus 4 divided by 4. You can check that this is the case, and then you need to check if you can do an additional factor, an additional simplification. Notice that here for this term, we can factor the 4. And then here we have 4x plus 3 times 4 times x plus 1 over 4. And since 4 is a common factor in the numerator and denominator, we end up with the answer, which is, let me write it on red, 4x plus 3 times x plus 1. Let's do example number 5. We have 10x squared plus 11xy minus 6y squared. One way to do this is to forget about the y and just factor 10x squared plus 11x minus 6. This is going to work when you have this configuration, x squared, xy, and y squared. Then you can forget about the y by now. And then to factor this one, we are in the previous case, right? It's similar to this problem number 4. Then we want to find two numbers such that the product is negative 60. Notice that in this case, a is 10. And we want the sum to be 11. What are these two numbers? Notice that alpha times beta being a negative number, it means that one is positive and the other one is negative. And then in this case, the sum is actually the difference. Let's see how can we write 60. 60 can be written as 5 times 12, or it can be written as 10 times 6, or it can be written as 15 times 4. And since we want the difference to be 11, here is our choice. Then we can take alpha to be 15 and beta to be negative 4. Then I can factor this as 10x plus 15 times 10x minus 4 divided by 10. Then we keep simplifying. And then here for this term, I can factor a 5. It's 5 times 2x plus 3. And for this term, I can factor a 2 times 2 times 5x minus 2 over 10. And here we have 5 times 2 is 10 divided by 10. And then we end up with the expression 2x plus 3 times 5x minus 2. This is the factorization of this expression, right? But remember that we needed to factor this and not this. Then the answer for this is going to be, let me just rewrite, 10x squared plus 11xy minus 6y squared. You can check that this is 2x plus 3y times 5x minus 2y. Essentially, at the end, you just include the y here and the y here, and that gives you the y and y squared. Then, this is the answer. Okay, this is it for this video.